Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is an analysis of a question. And the question is, what would programming look like if we had AI agents all along? So from the very beginning. And I find this question interesting because I believe these types of questions, which can be called beginner mind or from the first principles, they can help us understand what is the direction in which software development will go with the influence of AI agents. Now, before I start, let me just state clearly that AI has multiple problems right now, and in particular, large language models. There's the problem of copyright. There's the problem of maybe learning from the questions and the documents that you place, so a privacy problem. There's a problem of bias. There's a problem of ethics, after all, and the energy consumption. So these are all problems that we understand, but I'm gonna ignore them for this analysis because we need to simplify somehow. So I'm gonna skip over those. Also, in this analysis, I will be a bit speculative. So I know that certain things don't happen right now. For example, agents don't actually have memory, but we're going to discuss about them like, in terms of what could happen. So it's more of a speculation rather than clear answers. And then we'll come back to what this might mean for software development. So what if we created programming now? What if we had already AI agents and we were able to have conversations with them? And let's assume they also knew and understood. Well, understood is not a good term. They were able to create programs, even though we don't have programming yet. So I don't know. They got teleported from an alien race that already did programming, but we don't know programming, or at least not the one that we created. So, and let me start with one thing. Let's look a little bit at the history of programming. And the history of programming is mostly about increasing abstraction level. We started with circuit level programming, which meant in some cases actually weaving the circuits. This is how the Apollo moon mission has created its programs. That was programming at some point, actually binding circuits in a specific way. And then we went to some computers that were programmed using switches. So you turn on and off switches, and those were basically zeros and ones. And then we went to machine code, which is, again, binary. And then we went to assembler, which is a textual representation of machine code. And then we went to lower level languages like C, which is a slightly higher representation. And then we went to modern languages, Java, C#, and so on. C++, modern C++, which are languages that don't take into account that much. At least when you are programming, you don't take into account the machine instructions. And we did this for two goals, for two purposes. One of them was portability, because we had different processors, and each processor had its own instruction set. It was very difficult to write a program that worked on multiple sets. It would mean on multiple CPUs. It would mean that you had to duplicate the code and adapt it for that specific CPU. And that was one of the reasons. And the other one was to make it understandable for people. Now, these two have always been limited by the level of precision, by which I mean you need to be very precise when writing software because computers don't know much. They only know precisely what you tell them, and they do precisely what you tell them. So because of this, you need to be much more precise in software development than in any other domain. And on the other hand, making it understandable means that we created other types of abstractions. So for example, we cannot have a program, or we cannot easily understand a program that is in a single file. We need to split into multiple files, into modules, into objects, functions. We created all these abstractions to help us manage complexity when we have more and more code that works together and does something. And now, what if we had AI agents? Because AI agents, they can do a few things. You can understand existing code through conversations with AI agents. You might not understand it perfectly, and they will make mistakes and so on. So obviously, AI agents have a problem with precision, which is what we call hallucination. So they are not precise enough. But this precision problem is not always a problem. So hallucinations can be a problem if the AI agent is part of a process that requires a high level of precision. But it's not necessarily a problem if it happens within a conversation, right? If when I'm discussing with an agent, if it tells me something that is incorrect, I tend to double check, when something looks fishy, and I find out, and so I figure out, yeah, that's not precisely correct. To me, it's funny. One of the things that I've noticed is that it keeps inventing WordPress plugins that don't exist. So that's one thing that I've noticed in terms of hallucinations. But what this means is that imagine that instead of having a program, you would have somehow an AI system that also has memory. And your development process would be you'd go to the job and ask and start a chat with, let's say you have a project BistoScribe, right? It's a smart editor. You can write all types of text, and and we'll call it BistroScribe because it sounds cool. And instead of having code, what you have is a conversation interface. And you say, "Hi, BistoScribe, how are you today? I noticed that we have a bug report from one of our users. When you input a markdown file with this kind of structure, they don't get the PDF output that they want when generating the PDF. So why did you do that?" And then the project will start explaining to you, "Oh, so this is what happens. So I got this, and this turned into this, and so on. Oh, okay, but now I want you to change this and make it work in this way." And it will tell you, "Oh, okay, so now I changed it. Cool, so now let's see the changes. Let's try the example again." And you run the example again. And it's all conversational. And this would lead to a few interesting things. First of all, you might not need programming languages anymore because you are discussing with this entity, right? The project is an entity that you can chat with. Um, Second, you might need GPUs instead of CPUs, because this thing would run on a GPU. So we won't need CPUs that much anymore, but we'll need much more GPUs. So that would be interesting, right? A third thing is this kind of job is more akin to an engineering psychology or robotics psychology or something like that, because your job is to chat with this entity and understand what you need to tell it and how to converse with it so that you get the desired results. So it's more like a psychology um, session than a programming session. Um, and this would be also, it's a kind of programming that would be by continuous approximation, because these kinds of programs will never work fully correct or fully precise in a way that in the way that you expect. But you would keep approximating and towards the desired result, which honestly is what programming is today as well. Only many programmers feel that it's much more precise. It's not quite. I mean, we always have bugs and we always approximate towards the ideal behavior, but and even with all the methods that we have, you still will have a small number of issues, even if you do everything perfectly. So this would be a programming with a continuous approximation. Now, there may be some issues with these styles of programming. One of them is regressions, since you don't know what happened, and since you don't know what happens when you add a new case, it might happen that old cases don't work as well anymore. So you need a way to retest everything, and so testing becomes much more important than the actual programming, because the programming is this conversation, but then testing, oh boy, that is very important. Of course, there may be security issues, because as long as you keep the conversation in a nice manner, all is fine. But when you try to exploit it, everything might start working really poorly. So you need some kind of protection against exploits, which I know we don't have right now. But maybe some kind of filtering, some other AI that is filtering the inputs, whatever. Let's assume that we have that, although it's not an easy problem to solve, but we are speculating right now. Another issue that might appear is when you have too many rules. So if you keep adding these types of rules, they will keep getting, they could get into conflict with one another. So the level of precision still needs to be quite high. So maybe instead of having this, you would have a suite of tests that you create through these conversations and that check that the whole system works perfectly, and that serve as an input for this entity, this program entity, to work, right? And it will say, okay, you are working if you cover these types of tests. So this would be a kind of programming that's different from what we have right now. And it might be quite interesting to see, although it would be very, very different. Now, this doesn't cover all the possible situations, because this is for the, let's say, more approximate kind of programming. the kind of programming where it's okay to get it right in 90% of the cases. But there are other situations where you need to get it right in 99.9% of the cases, like in life critical systems, maybe more nines than just one. In life critical systems, you might still need to write code in the way we know. So that would not completely eliminate this. Also, you might need very specific libraries. So let's say if you want to build libraries that support physics or that support mathematics, or these are sciences that can be encoded within programming libraries and just you keep them and they are used by these types of programs. So this would be another thing that we might consider is, in this way, maybe you won't need code as we know it, but you still need the program to tell you and to communicate with you in some way what it's doing, and in a way that is actually precise. So maybe you will still have code, but not as implementation, more like a communication mechanism. You don't know exactly what's inside this program because the way you are building it is telling it, okay, I want this behavior to happen, and now I want this behavior to happen, or I want these 200 behaviors to happen. And the behavior is an input, an action, and an output. And that's how you define the program. And that's how you test it, and that's how you add. And when you converse with it, it keeps adding to these behaviors. But when you want to go into more details to understand what it's doing, it might need to tell you, okay, so in Python, this is how this would look like. It's not what I'm doing, but it's a way to communicate with you, a person, a human, what I am doing actually in very precise ways, because code is still the most precise way of storing knowledge and transmitting knowledge. So yeah, this is an interesting theory. Now, the next question is, will we get close to something like this? And I don't know, honestly. I don't know. I've been using these agents for a while. My feeling is that there are two parts to it. One of it is they will develop and become more and more capable in time. And perhaps there will be two types, some of them that work on very specific domains, and some that work on more general domains. But the next part is how good will they be? Will they still make a lot of errors, a lot of issues? And there's also a psychological aspect here, because my feeling is that the biggest change in interaction with computers for people is when you interact through applications, they behave most of the time, like 99% of the time, in a deterministic way. You put in an input, you do an action, you know that the output will be something that you expect. And this is how how our users got used to computers, right? This is what you expect from a computer. But now when you discuss with AI agents, on one hand, it's interesting because they give you surprising results. But on the other hand, you don't have the same level of determinism. So when you pass in a specific input and do something, you don't necessarily get the same output. And this might prove to be a problem for this kind of software. On the other hand, yeah, who knows? It's very difficult to figure out what the market forces will be here. I've recently read an article, I think by Cory Doctorow, about two visions for AI, for using AI agents in the field of work. And one of them is a kind of augmented intelligence, where you have people who are helped by these assistants. But the other one is a reverse centaur model. And the reverse centaur model is more about, because of the market forces, we will have a lot of agents doing a lot of work and one person running around trying to fix their mistakes. And I'm afraid this might very well happen unless, the domains are more regulated and a specific level of quality is expected from them. But there will always be a push towards, reducing the costs, and reducing the costs in this case would mean, okay, how about I pay 20 agents for 100 euros each per month, and then I have one person figuring out their mistakes and sorting them out and solving them. And that's economically, it sounds like a much cheaper model. It doesn't necessarily fit what I would like to see with AI, because I believe these tools can be amazing if we use them with people and if you actually do augmented intelligence. So that's one possible future for that. So anyway, with this being said, this was my analysis for this question. What do you think about this? What are your comments? What are your thoughts? Have you used agents? What are the limitations that you've seen? What have they been useful for? Let us know in the comments. We love comments, and I love to answer to comments. So yeah, let us know. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.